Can I write like this? The third term is 5. 5 means the first term plus 2 times the common difference. Am I right? Okay, there are many sequences, many list of numbers, many number patterns. But arithmetic progressions are only one progression having this property, such that to get each term in this list, we have to add a fixed number to the preceding term, to the previous term. That's a property of arithmetic progression. And in arithmetic progression, the number we add is called the common difference. And we denote it by small letter d. And the first term we denote with the small letter a. The common difference can be positive, negative, or 0. We did some example question to find the common difference, and we also discussed the general form of an arithmetic progression: a plus d, a plus 2d, a plus 3d, etc. Okay, to get the second term, we want to add the common difference to the first term. The first term is a, common difference is d, so the second term is a plus d. And the third term is common difference added to the preceding term, second term. So a plus d means a plus 2d. So that's this general form of an arithmetic progression. It goes like this. Okay, and we also discussed the finite and infinite arithmetic progression. So in finite arithmetic progression, the sequence will terminate at a certain point, and this is the first part of arithmetic progression. Okay, mainly one thing. So I will divide the chapter into 3 parts. First part we finished arithmetic progression introduction, the terms, the common difference, and first term, and the general form, etc. Okay. And the second part, very important part, as an nth term of an arithmetic progression. We'll see the idea, what is the nth term, and then we will divide a formula to calculate the nth term. Okay. Derive the second step you can see in this file, derive a formula for nth term of an arithmetic progression. We'll see some applications of this formula. Okay. And there will be a third part, we will discuss the sum of few terms in an arithmetic progression. Okay. So the second part we start today. So here we discuss nth term of an arithmetic progression. Okay. Then we will divide a formula for nth term. Okay. So I write a sequence here. Okay. I start with very simple arithmetic progression: 5, 10, 15, 20, etc. So can you say the common difference in this sequence?
5.
5. So 5, 10, definitely an arithmetic progression, and it follows the definition. The first term is 5, and the common difference is also 5. Okay. So or you can say the multiples of 5. Multiples of 5 is the sequence is an arithmetic progression. Okay. So here we know the common difference and the first term, very important. Okay. If you get the first term and common difference, we can form the sequence. Okay. Then if you get a sequence, you can find the first term and common difference, no problem. You know how to find the common difference, and to find the first term, there's no difficult. You can simply look and write the first term. Okay. So here A1 is 5. Okay. So I simply write 5. A1, you know A1 means the first term, or simply you can say A, no problem. Okay. Then second term is 10. Okay. To get 10, what do we have to do? We want to add 5 to the first term. 5 means first 5 means the first term, and second 5 I mean the common difference. So we have to add common difference to the first term to get the second term. So 10, the second term 10 is got by adding 5 to the first term 5. Okay. And the third term 15. Third term 15 is got. 15 is equal to the first term 5 plus 2 times common difference. Am I right? So can I write like this? The third term is 5. 5 means the first term plus 2 times the common difference. Am I right? The third term 15 is equal to first term 5 plus 2 times common difference. Right? Yes. So fourth term 20 is equal to 5, the first term, plus 3 times the common difference. Am I right?
Yes.
Okay. So the sequence goes like this. Okay. To get the second term, we want to add 1 time the common difference to the first term. To get the third term, we want to add 5 plus 2d. 2 times common difference we have to add. I wrote here 15 is equal to 5 plus 2 times 5. Here, first 5 means the first term 5, and the second 5 represents the common difference. Okay, and 20 is equal to 5 plus 3 times 5. Okay, and sequence goes like this. Okay, so we all know that this is the sequence is multiples of 5. So 50 will be the 50 will be there in the sequence, and it will be the 10th term, right? 50 in this sequence, in this progression, that 50 will be the 10th term. Am I right? Okay, so how can we write this 50? So if we continue like
9 into 5 plus
5 plus
the first term 5 plus 9
into 5.
Yes, 9 into 5. Okay, so 5 plus 9 times 5. To get the 10th term, we want to add 9 times the common difference to the first term. Okay, to get the 10th term 50, we have to add 9 times the common difference to the first term 5. Okay, now we are going to derive a formula for nth term. So this was an example. So now we go to general form and using algebra. So sequence we can write like this: A or A1, no problem. Then second term A2, then third term A3, then A4, then A5, etc. Okay, so you know this. So in the last lesson we have discussed it like this. Okay, any arithmetic sequence we can represent the terms like this using suffix. Okay, so any letter you can use in state syllabus, they always use like this: x1, x2, x3, etc. And no problem, you can select any letter, no problem. Okay, so here I select like A with suffix, so A2, A3, A4, etc. So, and common difference we usually denote by D. So D is the common difference, and A is the first term. A is the first term, and D is the common difference. Okay, the second term A2. Okay, second term A2 we can write as A1 plus D, right? First term plus 1 time the common difference. To get the second term, we have to add common difference to the preceding term. So A1 plus D, right? And to get A3, the third term, we have to add 2 times the common difference to the first term, right? So A3, the third term, is got by adding 2 times the common difference to the first term. If you add 1 time the common difference, you will reach in A2. And if you add 1 more time, you will reach in A3. So that means A3 is equal to A1 plus 2D. Okay, and to get A4, the fourth term, we have to add 3 times the common difference, right? A4 is equal to the fourth term, A4 is equal to A1 plus 3 times the common difference. If you continue like this, how can we write A10?
A1 plus 9D.
Okay, so A1 plus 9D, very good. A1 plus 9D. So you got some idea. So I think we can now, you can form the general form. Before that, I'm not writing. You simply say what will be the 100th term. A100.
A1 plus 99.
Yes. So you have to note this number here. So here in all these A1s are same, and this column is not changing, and this D is not changing. Okay, and D is not changing, and the suffix, the position number, and the number of D, common D, are changing, but there is a relation. When the position number is 3, the number of D common difference we add is 2. That is 1 less than 3. Okay, and when the position is 4, the number of common difference we add is 3. That's 1 less than 4. And when the position number is 10, we add 9 D's. one less. Okay, so if you continue like this, so suppose I take the general term, any term in this sequence, so I can represent by an, the nth term. Okay, n can be any natural number, so an can be written like this: a1 plus how many d can you say?
n minus 1d.
N minus 1d. So it should be one less than from the position number. So, and I choose the position number as n. So one less than the position number n means n minus 1. So n minus 1d. So we should use on the bracket here, otherwise we will make some error. Okay. So an is equal to a1 plus n minus 1d. In any arithmetic progression, a1, a2, a3, a4, etc., the nth term an is got by this formula. An is equal to a1 plus n minus 1d. Okay, in words we can say the nth term is n minus 1 times common difference added to the first term. Okay, if you add 9 times the common difference to the first term, you will get the 10th term. If you had 99 times common difference to the first term, you will get the 100th term. And if you add 9 minus 1 times common difference to the first term, you will get the nth term. Okay, and this is the formula to find the nth term of an arithmetic progression. So come back to PPT. So here, this is the formula I wrote here. The nth term of an of an arithmetic progression with the first term a and common difference d is given by an is equal to a plus n minus 1 times d. Okay, so I hope you understood the idea of nth term. This formula has a wide application in many different problems, so you can use this idea to find the solution. Okay, and two terms here, general term. So an means the general term, right? So a1, a2, a3, a4 means the fourth term, a5 means the fifth term, but an means here n can be any number. That means an is the general term. Okay, we have studied general form of NAP, and here general term. There is a difference, right? General form of an arithmetic progression is a comma a plus d comma a plus 2d comma etc. That's general arithmetic progression. But here general term of an arithmetic progression, so that is an. Okay, and the last term we usually represent by am, or sometimes we use small letter l to denote the last term. Okay, if the sequence is terminating, if the sequence is finite one, then we will have a last term. So in such cases we can use am or l to represent the last term. Okay.